forward to this computer. Okay, there we go. Now we're ready to start. Today we're going to start with these things called stacks. Okay, and we're going to come. It's going to be a brand new data type. A stack is a data type, an abstract data type, but it's a data type that we're going to work with. And in order to work with this data type, again, I keep saying data type. In order to work with this data type, I'm going to need to keep in mind the two things that we've just talked about: the arrays, pros and cons, the linked list, pros and cons. What was the con of the linked list? They're hard. And we just mentioned a moment ago about how yeah, that's just a definite con. Until I get used to working with these, they seem a little bit hard. How I break the habits of I got to draw it and look at it before I start to program it. Now, this data type stack, it's going to be like a stack of plates. I was just telling a story about a stack of wax, which were the 45s that you put on top of the arm and you stack them up, you put one on. But anyhow, we're going to think of this as a stack of plates in your cabinet. Okay. We're going to think about this as a Pez dispenser. Everybody knows what a Pez dispenser is. You push one in, then you push it down to put the second one in, push it down to put the third one in, which leads to a good trivia question. How many candies were in one of the packages of Pez that you put in the Pez dispenser? I run trivia once in a while, so that's yeah, it was a good question.
Like 12?
It is 12. Andrea Googles faster than the rest of you.
No, I actually didn't Google it. That was a guess.
Okay. All right. So way back in 121, we had the word LIFO on an acronyms page. Those of you who had me for 121. And I said, yeah, it's last in and first out. And we're going to talk about that in CPS 162. So today and Monday, we're going to talk about stacks. We're going to look at Gaddis's approach, and then we're going to use the NIOP book and say, well, when would I ever use this data type? Okay. So stack, LIFO, the last one in, the last one you put on the top is going to be the first one that comes out. We are going to need two functions. One is going to be called push. That means I'm going to push it on the top. And then, some of them push down like that Pez dispenser. And then I'm going to need a function called pop that's going to take it right off the top. Okay. Push and pop. These guys are functions that I'm going to use.
That's
Got
like
the
the vectors, right? Because vector also uses a push back and a pop.
yes.
Yeah.
Yes. Yep. They are functions that are already written. Good point.
Okay.
Okay. So now I have an array and I want to get ready and I want to put things in the array. And I'm going to do, I'm going to do some stuff like, so if I say push, I'm going to push 5. That's going to go in. And, we're going to think of that as being all the way down on the bottom of this stack. Then if I said push 11, that's going to go on top of that. Push 5. You notice that I'm sending a parameter in. The number that I'm pushing, I'm going to send a parameter in. Push 11, I'm going to send a parameter in. Pop would now take the 11 out of this list. It's going to take it off the top. Push, I'm now going to put the next number in, which would actually be in this location. What's really cool is on Monday when we start saying, well, let's do this and work with pushes and pops and how it's relevant to writing programs to solve types of problems, then it becomes really neat. All right, so let's play. Let's go with the array first. And I just made some comments. I said push 5, push 11, pop, push 14. How do we want to make this work? Well, push 5, I know 5 is going to go in that first spot. Would you agree? Yeah. Yeah, I think I'm pretty good with that. The 5 is going to go in the first spot. Now, where can the 11 go? Where could the 11 go?
It could go on the second one, right?
It could go in the second one. Where else could it go?
In front of the five,
In
pushing the
front of the
five back
five,
one.
right? So if I would insert it in the beginning, I would have to shift everything. And yeah, yada, yada, yada. Pop. What will happen when I pop?
If you put the 11 up front, wouldn't you have to shift everything back forward one? Whereas if you put it afterwards, you could just effectively delete it out.
Yeah, yeah. Think about that a second. So I have this whole shifting going, and I just okay. So I'm gonna do which one do we like the best? Putting it at the end. So really we're thinking of this as if I took this backside and swung it around so that it would look like this and my five is here kind of idea. All right, so if I put the 11 on the end, and that's okay, so let's just say I said push five, push 11. What if I then said push two? It's going to put two on the end. And then if I say pop, that two is going to come out. So is it probably easy to do that pushing and popping? Well, we said we don't have any shifting that has to go on, anything like that. So when I'm doing stacks and I'm using an array, I'm going to add to the end and I'm going to pop from the ends. Okay, there's a reason I'm doing this. There's a reason I'm doing this because today we're doing LIFO. Next Wednesday, we're doing FIFO, and we're going to be talking about the same kind of things. Instead of a stack, we're going to be talking about a queue. Okay. But for now, I need to keep things straight. I need to go clear. It's almost like I took this left end and swung it around. And whenever I push, I'm adding it to the end. And the 11 would go here. So this is going to work out right. I'm adding to the end and I'm popping from the end. What's something I'm probably going to need to make this work fairly efficiently? How do I know where the end is?
You would need a counter.
Yeah, I'm going to need some kind of counter to keep track of things. Right now, my count is three. I know my ending location is one less. So if I had to write code for push, I would be, so right now the count's at three. If I said instead of pop here, push eight, what location would I put that at?
You put it in 4.
Well, not yet. I would put it in three and then add one to my count. Because remember, an array starts at zero. This goes zero, one, two. Yeah. Yep. Okay. I think I could write push and pop. Pop would be go to, I said pop right now. I want to get this. I would go to count minus one and then subtract one from count. Okay. Y'all think you could have done this without me drawing a picture? I'm sure you could have. Yeah. 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 That's sarcasm, Sheldon. All right. Let's take a look at linked list. A linked list. Linked list, of course, we know is going to look something like this to start. If I push five, head goes to five. Now I'm going to push 11. Something else to keep in mind. The LIFO. The last one in is the first one out. If I add to the end, I better be popping from the end because that's where the last one is. So these guys are going to be the same. I'm going to bet that these guys are going to be the same also. Where would be the best place to add something now and retrieve it?
I think from the front,
Yeah.
because you set the new value, um, the head equal to the new value, and you have a temporary pointer that's keeping track of the previous head, and then you set the new node next to the previous head. Yeah. It's actually very similar to the approach that we took on Monday with my like reverse function.
Mm-hmm. I hope you
Um,
guys had a chance and looked over some of those solutions that were posted. That one group tried to be sneaky and just display 340 because that was that one set of test data we used with 4, 4, and 4. But a lot of folks had trouble just doing the inside part first. Once you got the days working, I mean, everybody thought it was, I think, may have assumed it was a little easier than it was, but that middle part got a little tricky, and location of certain lines played a big part. One line had to definitely be before the other. And groups had printed out a whole table, made it very user friendly. It made it easier to check. One group even took my advice and started to throw in see outs at random spots to see what values were there or to see if it was getting to that line of code. And Jack and I even had a conversation about that recently as well. Just throw in random see outs
mhm.
and look down in that console window and see what's going on. Did it get to that line of code? Is it doing it once? Is it doing it 100 times? So coming back to this linked list, yeah, I think, and I think whoever is going to be in Andrea's group, she's already got an idea of how to write the insert. Heads, new node, new nodes next gets the value of head. So it would point here. Head now gets the value of new node. So for this guy, yes, we are going to add to the front and we are going to remove from the front as well. Do we have to do lots of shifting? No, none at all. Do we have to traverse to get to the end for some reason? No, not at all. Over here, we are able to get right to the location. So efficiency is good. All right, so I'm going to put you in some groups. Let me see, how many do we have? 14. I can make 4 groups. Group 1 and 2, you are going to write a push and a pop function for the array. Group 3 and 4, you're going to do linked list. Okay, you're going to write the code for it. Now, I would like the function headings as well. The function heading, not just a couple lines of code, a complete function. Everybody with me? 1 and 2, you're doing arrays. 3 and 4, you're doing um, the linked list. Okay, I'm going to pause the record. Okay, so I'm going to start by going to here, and I drew me an array just because I need to keep an eye on the picture. I'm not going to ask any groups if they did that as well, but I drew it to keep an eye on everything. I'm going to work with the arrays. Um, I'm checking if the number of elements is 0 because I'm assuming number of elements is declared up in, it's one of my original identifiers in this class. Num elements, the num array, all of that's going to be declared so I can use it in my functions. If it's empty, I add one to num elements and I insert it at where num element at 0, putting it in the first spot. If number of elements equals array size, that means it's full. There's a good chance that is empty and is full would be functions that are written in this class. I could use those. Otherwise, I add the value and I increment the number of items, the number of elements, the count, whatever you want to call it. And I just did a little scribbity over here, keep track of it in my head. If I jump down to here,
Question.
yes, question. Go ahead.
In your else, wouldn't it be num element -1?
Number of elements, that's possible. So if this is, so right now the number of elements is 2, or excuse me, the number of elements is 3. I want to add this to the third spot and then increment it to 4. Guess how I figured it out, Jack? Say it. Say it.
You drew a picture and I
I-
didn't.
I drew the dang picture. Okay. All right. Can you tell I fought this battle before for about 25 years? Yeah. Quick question. Does this first else need to exist? If it's empty, would this else take care of it? Group 1, you already know the answer to that. Oh, we wouldn't need it. This takes care of it. That's right. Nobody from group 1 wanted to admit being in group 1. Uh-huh. Sticking with arrays. If it's empty, again, if is empty, print out some kind of message. Otherwise, I want to return the value from the array and subtract 1 from number of elements. Do we care if it's still there? I popped. See, I created a question because I drew the picture. If I pop and this is gone, do I care if that 9 is still there? What's in your array to start?
It's
Probably
empty.
all zeros, maybe. I don't know. But we only need to keep track of how many there are. The rest of this is just junk in memory. So no, we don't care if it's still there or not. Someone from group 3, you want to share what you had? Now we're switching over to linked list.
We were about, I'd say probably a quarter of the way there,
Okay.
but we did like the if not head,
But
and then we set the new node value to the number for parameter. And then we set head equal to new node, and then
right.
we made new node point to next, or new node that points to next, and we set that equal to null. That's about as far as we got.
Group 4, do you want to share on screen what you guys had? Someone in
Sure.
the group had a
Yep.
pretty good idea early on what to do, and here it comes.
Nope, that was the other one. Oh, here we
Okay,
go.
so push node. It's going to bring in a value, create a new node, set new nodes next to null pointer. New node's value gets the value of val. Boom, good. If head is null, head simply points to new node. Otherwise, new node's next gets the value of head. Head goes to new node. That's it for push. That's it. I even got the comment, this is probably easier than it would be to do this by way of using arrays. And as we go through the rest of the course, that's what you're going to see. There's going to be times where doing an array is the preferred way. There's going to be times where you're going to see that a linked list is the preferred way to create a new data type like we've just created. Pop, if head is null, it's empty. Now, otherwise, we're going to create a temporary pointer that gets the same value as head. This is taking it up a notch. Head gets temp pointer or heads next, so it moved to the next one. And we don't want to return temp pointer. We want to return that value. Correct?
Yeah, so that's what we were going to ask is just the
Yeah.
order of how this works is you would return the value, you would first delete the temp, then return the value, right? That's the order you'd want to do this.
I would once temp pointer up above gets the value of head. Yeah, you want to return temp pointers val. That's all you'd have to add on there. So just at the end, do the dash arrow val.
Oh, okay. So then this wouldn't be returning a pointer. It would be returning a
Value.
int.
Yes. Yes, you want to return the value. And in group one, we talked briefly, do you want to do it as a return type or do you want to do it as a reference variable? Couple of things. But you notice they also have delete temp pointer. That's deleting that node that we just returned the value from. Would that look easier in a picture? Has everybody got it?
I mean, probably, but those are harder to put in Microsoft Word in
Yeah.
like 5 minutes.
Does anybody want to see it with pictures or not?
Sure.
Sure.
Oh,
Yes.
well, our group did have a question about, so the order of returning and deleting, in most of the cases up to this point, like return has worked as like the functional end of the function. Like that's usually the last line. So would it do that and then read the delete, or would this just kind of send this and then disappear?
Maybe that's where we have a reference variable. Coming in as nothing, but that variable gets a value to be returned.
Yeah, that's what I was trying to
Oh,
say.
okay.
If you remember, I was trying to tell you that like maybe we have a variable so that you can first delete the temp data, then return the value.
Ah, okay. I misunderstood.
Yeah, yeah, I was doing a bad job of explaining that.
That's fine. Stop sharing for a second.
Oh, okay.
Then has points to a list. We're going to get rid of this. We're going to send temp pointer to this node. So it points to this node. Head is now going to get the value of heads next. So that means this line is now going to be pointing to here. So this was first. This was second. Third, I want to return the value. I want the 6 to be stored somewhere, store or return, so that I can get that. So that's actually going to be temp pointers value. And then last, we're going to destroy temp pointer. We're going to destroy this node. Okay. Group one, share the code for what was it called? No, it wasn't called int list. What was it called? You were just looking at it.
Int stack.
Int stack. I apologize. It is int stack. Int stack. You had it on the screen when I was in there last.
Yep.
And we're going to take a look at, here is the function. This is integer stack push. So this is a class called int stack. And it's all kinds of stuff is going to go on inside of here. This is probably the implementation file. Is that correct?
That is correct.
That's correct. So here's the implementation file. Here's push. If it's full, see out the stack is full. Otherwise, I'm going to add 1 to the array and then put the number in that spot. Nice, clean, and simple. The more you work with this, the more you're going to be able to finesse your code down into that. by order, 15 and 16 have to be a certain order so that I'm adding it to the right spot. But if you had a picture and you had a top value and da da da, it would all make sense. So somebody might come to me and say, I don't understand the push. And I would say, okay, draw the picture and then come back, and I would never see him again. Pop, check to see if it is empty. So we know that's going to exist. Otherwise, I'm going to go in the array and get the last item and subtract by 1. Int stack. Now there's another one called dynamic int stack. Okay, this one is arrays. This one is arrays, and it's out of the Gaddis book. You're going to see code when we go to the NIOF book. Instead of int stack, they're going to call it something else. Does anybody have dynamic int stack, the implementation file that we can pull up and look at push and pop real quick?
I think I have it.
Okay. Now we're going to think about what group 4 had. And again, here we have, what do we have going on? Inline. No, we don't want that. Go down and find the push and the pop.
Just push line 31.
Oh, I'm sorry. I do apologize. I'm sorry. So in line 31, we are going to take a new node, insert value. In line 37, we're putting the value in the num. 41, we check to see if it's empty. If it's empty, top equals new node's next equals null point. What is top?
Top the stack.
Yeah, what's it replacing? What word have we been using up to this point? Yeah, we've been using head. Now all of a sudden they're putting the word top in there. So top gets the value of new node's next pointer. Line 44 could have been up at 37 and a half. I could have done that right away. Okay. If it's not empty, new node's next gets the value of top. That now points to the first item that's in there. Top now gets the value of new node. So looking at these solutions, all of a sudden you're going, oh boy, that wasn't too bad. Scroll down, we can see top, dynamic int stack. Dynamic is the linked list. It's dynamic. And we go in, check to see if it's empty. Yeah, look, there we're doing the whole delete top and on. Some things going on inside of there. Okay. Now, how is it being returned? Where's the value stored? What line number?
Stored in num in line 70.
Line 70, it's stored in num. And as you can see back up in line 59, it's returned as a reference variable, which is going to make it a lot easier to work with. Okay, that took care of the question that group 4 was actually working on. Cool. Stop sharing, please. And that is CPS 161. We are CPS. I'm going to page 1120. Thought I already had this marked. Clearly I didn't. 1120. And I'm going to take a look at number 7. Number 7. The dynamic math stack. Dynamic. What am I talking about? Arrays or linked list?
Linked list.
Linked list. Okay.
It's 1220. The page is 1220.
What did I say? I'm sorry.
1120.
I apologize. Page 1220. Okay. So included in this is something called math stack class. This math stack class has 2 functions in it, add and subtract. How do you think I would add from a stack? Well, I'm going to add, I'm going to pop the first number. I'm going to pop the second number. I'm going to add them and put them back in the stack. Same with subtract. Pop, pop, subtract, push. What if we added some members to this class called Dynamic Math Stack? Could you add multiply? Well, it's going to be a lot like the add was. Pop two values, multiply them, and push it back on the stack. Could you do divide? Could you do add all? So for the rest of the class, what I want you to do is use the math stack class and add three more functions. So can somebody go and pull up mathstack.h, please? Now, guess what MathStack is going to use? Thank you, Casey. Guess what MathStack is going to use? Line number 4. Yeah, it's going to use int stack. That way, everything that's in int stack, I can use, particularly push and pop. So I'm going to be able to, what was that called? Line 6 makes that a, is that a friend or something like that? Something along those lines. Okay, so in MathStack, as you can see in the specification file, I have add and subtract. Can you go load up the implementation file? And add is written. Where is it? MathStack. There's add. Pop, pop, add them together and push them. Subtract. When we subtract, we have to check out that pop the first one, store it in difference, pop the second one, then subtract it, and then push it back in. So really, multiply shouldn't be too bad to do. Divide shouldn't be too bad to do. Add all is going to be the one that's the challenge. Show me the demo file, please. Did it come up? Boom, boom, boom. I don't know which one it was off the top of my head. I saw the word vector there. I'm looking for math stack, and I don't have it in my notes.
20, is it 2?
20-2?
Yeah.
Math stack. And that just simply says push 3, yeah, that would work. That one, what is it again? 20.2. Okay. We're not working with arrays. We're working with linked lists. You're adding multiply. That's just to get your feet wet. You're adding divide. Okay, you're getting a little better at it. Then you're going to do add all. So however many numbers are in that stack, you're going to add them and then push that final total back into the stack.